All right, I want to continue, and I want to teach you a little bit. This might take a little bit of doing, but when we're doing measurements, and you're going to have to do this in your science class as well. But when you make a measurement, these are the rules, and there's only one set of rules, so please write these down. Okay, you can do it later on. You can write it down based on the video if you don't get it right away. Okay, you have to make, you measure to one estimated place value. End of conversation. Complete period, nothing, no debate, no discussion. Look up here, not outside, not at somebody else. Look up here, listen carefully. You must do one estimation. When you have a scale, and you've seen this, it reads in here, correct? Isn't that an estimation? If this is 0 and this is 10, what would that be? 5, but what place value? Ones, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? One's place is changing, isn't it? Correct? Yes or no? Yes or no?
Yes.
Okay. How about this? What place is changing? Girls. What is it? No, what place value is it? Let me try this again. You ready? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. What place value is changing? Tens, right? So what you do is, you say, okay, is that the smallest graduation? That's a graduation. Those are, what place values are the big graduations? It's going 0, then 10, 20, 30, 40. What's the largest graduation? These are called graduations. What place value does the larger graduation represent? Which one? No, guys, look. 10, 20, 30, 40, 50, 60, 70, 80. Tens place, right? So what does the smallest graduations represent? Ones place. Okay, now, so isn't this area in here a place value? Isn't it estimated? In other words, look. You do it to me. What's this value right there exactly in between? What's that value? What is it? What is it? 3.5. That's right. Are you relatively certain that that's 0.5?
No, it's an estimation.
It's an estimation. What place value is 5 in? Tenths, right? So do you see that tenth place is the estimation? Isn't tenths place one less than ones place? Isn't it? So up here you say plus or minus tenths place. This was what that means. So in other words, this is uncertain. This is uncertain to tenths place. Does that make sense? Am I being clear? Have you ever heard of precision? The word ever. Have you ever heard the word precision ever in your life?
Yes.
Yes. This is precision. That's what the word means. It's the uncertainty. Isn't this measure uncertain to plus or minus a tenth? Couldn't this be 3.4, 3.6, right? Isn't it an estimation? The estimated place value is the precision of the instrument. That's it. Period. End of conversation. I just told you everything you need to know about measurement. Everything. I did. There's nothing else. You're finished. What's this value here?
It's not really touching. It's like 59.9 meters.
I'm not sure I want to do that right yet, but that's, I will in a minute, but let's do this one instead. Let's say halfway between these two.
35.
No, oh yeah, 35, right? 35. 35. What place value did you estimate?
10.
Ones, right? So every measurement must have ones place. So in other words, look at this. If the reading was right there exactly, what would that reading be? And if you were in my science class and put what I think you're going to put, I would put 0. 0 on your paper. No credit. What's that measurement?
70.
7?
No,
7?
7.
7? Is that what you said? 7? Is that what you're saying? 7?
Yes.
Wrong. No credit. 0. 0. 0, 0, 0. What must be in, something has to be in tens place. So in other words, are you estimating that it's right on the line? How do you demonstrate that the estimation is right on the line?
Low battery.
Says low battery?
Yes.
Okay. It'll just have to be good enough for the next minute or so. Okay. How do you do it? How do you demonstrate that you're estimating it right on the line? Isn't this the tens place? Anybody have Mr. Mike for science? You all do? Isn't this what you're doing?
No.
No, maybe that's with the 8th grade, but this is what you'll do next year. Now, how do I represent this?
60.
But how do I write that?
60.0.
No?
No, just
60. Yes.
You put a written decimal point in. Believe it or not, don't argue with me. It's the way you do it. See that? That's important. Now listen to me carefully. The next 2 words together will come to haunt your life for the next 7 or 8 years. These are significant figures. Listen carefully, you heard it here first. A significant figure is any figure, any digit that's read off a scientific instrument. Is that 0 read off an instrument? Yes. That has a function that says that arrow is right on that line. I'm estimating it to be on that line. So did that 0 come from that instrument? Yes or no? Don't let me lose you. I want your full attention. Did it? Yes or no?
Yes.
Yes or no?
Yes.
Okay, good. Let's look at this one. What's the estimation on that? What's the estimation? What place value? It's always one place value less than the smallest gradation.
350.
No. I didn't ask you what the measurement was. I asked you what the precision was. No? That's thousands. That's tens. Sorry, that's thousands. That's hundreds. So what's one less than hundreds?
10.
Tens, right? Sorry, guys. That's not easy. Did I break any rules? Didn't I do exactly what I told you to do? Isn't it one less the smallest graduation? Isn't this obviously thousands?
Yes.
Right? Isn't this obviously hundreds?
Yes.
Isn't this obviously tens? What's the value here? 1,350. Yes or no?
Yes.
Yes or no?
Yes.
Okay.
Yes.
Is that 0 from the instrument? Nope. Because that is the precision. So that 0 is not from the instrument. That one is. What's this one going to be? Come on, you can do this.
600. No, wait, 700. So that will be 1,700.
Is that 0 from the instrument?
Yeah.
Yeah, it is, because it's saying that it's right on that line. So that gets a bar. When the 0 is on the end and it's significant, it gets a point. When the 0 is here, it gets a bar. Is that 0 from the instrument? No. Check which ones came from the instrument. Did 1 come from the instrument? Yes. Did 7 come from the instrument? Did 0 come from the instrument? Did this come from the instrument? No. How many significant figures are in that measurement? 3. That's measurement. That's all there is. It's all she wrote, girl. All. Clear? Yes or no?
Yes.
Yes? That's how I want all those problems done. Clear? Yes or no? Okay, F, E, comparing decimals. Okay. It says, write in order from smallest to largest. Right? Write in order from smallest to largest. Right, you ready? It says 8.66, 8.6, 8.606. Smallest to largest. All right, what's going to be the largest? Can you do this? Is this pretty straightforward? What's the largest number? A is largest. So we'll give that a 1 as largest, okay? What's next largest?
C.
C. That has 0.06 more, right? And that's the smallest. That's pretty straightforward, don't you think? Yes or no? Okay. Let's do this one. 150 and 0.15. 150,000 and 0.15. 150 and 0.15. Which is larger? We'll say A and we'll say B. Okay, which one's larger? Maybe you want to write them both down as decimals. Okay, so what do we got? Which one's larger? Mathematically, they're the same. Mathematically, they're the same. You see that? Yeah, they're mathematically equivalent. Okay? Easy? All right, let's go on to the next section. All right, it says, all right, when we add, what do you have to do when you add? What do you have to do when you add?
Line up the decimals.
What is it? You line up the decimals. 0.2, let's do 0.9 and 0.23. 0.9 and 0.23. See how the decimals are lined up? And then you add it just like anything else. 3, 1, 1. Easy? Yes or no?
Yes.
You're sure?
Yes.
Okay, good. And then, same thing with subtraction. And then in multiplying by powers of 10, what do we got? Multiplying and dividing by powers of 10, what do we have? Right, for instance, these are the underpinnings of scientific notation, okay? Underpinnings of scientific notation, yes? So if I said 0.98 times 10, what would that be? Is the number going to get larger or is it going to get smaller?
Larger.
It's going to get larger. So you're going to put the decimal place this way or this way? To the right or to the left?
To the right.
Yeah, you got to make sure you interpret correctly. So what would be the answer?
9.8.
9.8. How about if I said 0.98 divided by 10?
You're going to 1.098.
1? What's 1? Right?
Yes.
You get it? Sure?
Yes.
Okay. Excellent. All right. Are we going too fast?
No.
It's actually very straightforward. We did multiplying and dividing by powers of 10. This goes on forever. Forever. Okay, I got 2 more sections left. All right, let's see. Let's look at multiplying decimals. All right? Now, this is something that I specifically remember from when I was a kid. Let's say I'm going to say, I don't like the way the book is doing it, so let's ignore the book. So let's say I say 0.3 times 1.12. How do I do that?
You just multiply 3 times 12, which you get 36. Then you look at your decimal points. Like on the first one, you have 1 decimal point. So it'll be 0.36. No. 0.036.
Yep, that's correct. Yeah. Yeah, that's 0.0.
0.
Now what do I do?